We are back now with a story that caught our eye about Vincent van Gogh's famous Starry Night painting. Here's a look at that painting. I'm sure you recognize it. He painted it in 1889, but it is now one of the most recognizable works of art in the world, known for its iconic swirly skies that are thought to reflect Van Gogh's stormy state of mind when he painted it. But new research finds that these famous swirls actually match up with our current models of atmospheric turbulence, and scientists think the troubled artist may have had a deeper understanding of these movements by studying the clouds and atmosphere. And luckily, we are joined by astrophysicist Adam Frank to help us understand it all. Adam, thank you so much for being here. Explain these findings to me like I'm a 5-year-old. What are we talking about when we say atmospheric turbulence?
Well, really, let's start with turbulence itself. So turbulence is this fluid motion. Fluids is like gases or liquids that we're all very familiar because we've all seen boiling water, right? Turbulence is any time in a fluid where there's enough activity that you get those roiling, tumbling motions. You get big swirls, and then you get little swirls, and they're all happening at the same time. And the amazing thing about turbulence, whether it's happening in a pot of water, or on the surface of the sun, or in an interstellar cloud, or in the atmosphere, it's all the same. It all behaves the same. And as much as it might look like chaos, there's actually these beautiful, deep relationships, physical relationships about energy and momentum that happen in any turbulent flow, that it seems like that Van Gogh, intuitively may have sort of understood by watching clouds, etc.
So it is not only the shape in this painting that's similar, right, but it's also the brush strokes and the colors. I mean, does that surprise you? Are these patterns things that you could typically see with the naked eye?
Well, here's the thing that really is amazing to me about this. I mean, this is like a deep geek dive.
Yeah, give it to us, please.
It's the mathematics behind the pattern, the mathematical pattern that when you look at turbulence, which just looks like a mess, when you cast it as a scientist and you take data and you examine the data in very abstract ways, you suddenly see that this isn't complex, it's very simple. For example, how many big swirls, in the turbulence there are, compared to how many little swirls there are, there's actually a very precise mathematical law that tells you that. And what it seems like is that when Van Gogh was painting those brushstrokes, the number of big brushstrokes to the number of little brushstrokes follows the same pattern. So it's almost like he was engaging with that mathematical law without knowing anything about the mathematics. He'd watched the world, watched water flowing over a waterfall or water boiling or clouds in the sky, and he kind of intuited what was happening there.
There are some people who will say, Van Gogh's style, it's fluid, he uses short brush strokes in a lot of his works. This is all just a coincidence. Do you think it is more than that? I mean, it seems like you really think he was understanding something, even if maybe he couldn't articulate it in the way that we would today.
I think, art has the capacity to capture truth just like science does. Often those are different truths. Like, you look at Shakespeare and the emotional understanding that he had about leadership, for example. It's not something science is really going to get. But also sometimes art can capture physical truths that also are expressible in science. He did lots of drawings of turbulent flows, of waterfalls, he was trying to see what really was happening there. So I don't think this is a coincidence. I think Van Gogh was responding intuitively, emotionally to what he was seeing in the sky, and was therefore sort of recapturing those patterns that then a detailed mathematical analysis would also find.
Talk to us about where the math and science was at the time he was painting this, 1889. I mean, were there people in academic spaces in the math and science understanding or starting to understand some of these more complex theories of physics and atmospheric dynamics, or was he really kind of just out there on his own in some ways?
He was out there on his own. Fluid dynamics, had been around for a while, but it didn't, we were still very early stage in the late 1880s in terms of the kinds of things that would eventually we'd come to understand about turbulence. Like there's this thing called the Kolmogorov spectrum. There's your buzzword for the day. That would have to wait until the 40s, really. So again, I don't think he was like getting the mathematics. It wasn't like he was, could write down the mathematics. It was that he was a human being in the world, responding to the world's beauty, the detail, the response to the motions that he saw in the sky, and was capturing a sense of what mathematicians would later on capture in mathematics. Because, the mathematics, it's beautiful to me. It captures in a different language. Like what he was doing was capturing in the language of painting what would later be captured in the very beautiful language of mathematics.
Wow. All right. Astrophysicist Adam Frank, thank you so much for being with us tonight and helping us to understand a little more about the universe. We really appreciate it.
My pleasure.